All right, here is the short video guide for lesson 3.2.3, looking at how can I use equivalent ratios. All right, more specifically in this lesson, we're going to be looking and practicing with our triangle similarity, that is using angle-angle similarity and side-angle-side similarity, the two that we learned in lesson 3.2.1 and 3.2.2. And we're going to see, okay, are these shapes similar, and then can we put it into a flowchart? Can we sketch a flowchart with the information to organize the reasoning and really prove that they are similar? And with that, we're going to move from those reasoning flowcharts with similarity into this idea of congruence and congruent triangles. This video guide is going to be pretty short because this lesson is pretty well laid out and step-by-step is pretty clear. So I'm just going to kind of give hints and tips along the way here. Starting here, just feeling how you feeling today, and I always like doing those to just get a feel when I go through the lesson how the class was feeling going into the lesson. All right, first one here, we're just looking at, are these triangles similar? Remember, the two that we know, the two that were on the board, the two that we're sure of in terms of triangle similarity, the conditions are angle-angle, so if they have two pairs of congruent angles, or side-angle-side, which again means proportional side, angle, proportional side, and that congruent angle needs to be between your proportionate sides. So you're going to look at this triangle here, these pair of triangles here, and say, do they meet those conditions, angle-angle or side-angle-side? If they do, you say similar. If they don't, you say not similar. And if they're similar, then you're going to draw a flow chart. Okay? So say you're going to say these are similar, and this is not exactly right, and it may or may not be right. You got to figure this out yourself. But if you want to say these are similar with side-angle-side, in a flow chart, that means we have a bubble. We have 3 fact bubbles. Okay? In each fact bubble, if you're using side-angle-side, you need to show a proportional side in one fact bubble. You need to show another proportional side in another fact bubble, and then you need to show that the angle between them is congruent. If you can show that, then you can draw lines to your conclusion. And remember, your conclusion is always a similarity statement. Triangle blank 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 is similar to triangle blank blank blank. And then down low below, you have to say that it is either angle-angle or side-angle-side. Okay? And that's for these triangles right here. As you move along, you'll see some other examples. Okay? We have another one here. We have to say similar or not similar, and same thing. Fact bubbles, either 3 if it's side-angle-side or 2 if it's angle-angle. You draw your lines to a conclusion. In your conclusion bubble, triangle blank 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 is similar to triangle blank blank blank. And below that conclusion is where this line is where you put your reasoning, really like angle-angle or side-angle-side. And you can see this next one's the same way. This next one's the same way. So a lot of practice there. And then this question's very good. It asks us to go back to each and find the missing side if possible. And if the triangles were similar, we should be able to find that missing side because we should be able to set up an equivalent ratio or able to find that zoom factor, and that zoom factor can help us find that missing side. Very good problem here. Here, we get this new kind of thing, still asking if similar or not similar, but if you look at the triangles, we're going to take this one a little bit further. So again, you're going to answer similar, not similar, and you're going to have to explain your thinking. And then we're going to take it one step further and say, this person believes that these triangles aren't just similar, they're congruent. And we're going to look at what special values in the flowchart indicate that the triangles are congruent. So again, we're going to use flowcharts. And I'll even say that this one looks like a side-angle-side problem. So we want to show proportional side, angle, proportional side, and that angle needs to be between them. Look at the ratio you get when you divide corresponding sides. That's going to help in this question. Look at the ratio you get when you divide the corresponding sides. Okay? Then we can write a conjuncture, if this, then this. And that, I believe, is the last question. We get to wrap it up here. And then there is a couple of actual homework problems as a bit of review here. So we can practice a little bit of and this problem's not on the homework that I'm assigning you. So it's good practice here at the end to just set up equivalent ratios or find zoom factor and solve for missing sides. Any questions along the way, please email me. Also remember, we have synchronous learning opportunities during your class hours on the day you're virtual. So you can always feel free to join those and ask questions and type questions into the Google Meeting chat then.